In this video, we dive deep into the top 25 Apache Spark in Microsoft Fabric interview questions for 2025. Perfect for data engineers, data scientists, and anyone preparing for Fabric Lakehouse, data engineering, or data science roles. We cover Spark integration, compute management, Delta Lake, notebooks, streaming, machine learning, performance optimization, fault tolerance, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What is Apache Spark in Microsoft Fabric? Apache Spark in Microsoft Fabric is a fully managed, distributed computing engine for large-scale data processing, analytics, and machine learning within the unified platform. It powers Lakehouse workloads, enabling ETL, ELT, data exploration, and advanced transformations on OneLake stored data. Fabric provides optimized runtimes with platform-specific enhancements, including integrations with Delta Lake and native execution engines. Spark supports interactive notebooks, batch jobs via Spark job definitions, and orchestration in pipelines for scalable workloads. 2. How is Spark integrated into Fabric? Spark is natively embedded as the core compute for data engineering and data science experiences, with managed clusters and autoscaling. It leverages OneLake for direct, zero-copy access to Delta tables and files, ensuring seamless data sharing across Fabric items. Integration includes starter pools for quick starts and custom pools for tailored configurations, with high concurrency mode for shared sessions. Fabric enhances Spark with features like ML flow tracking, Copilot assistance, and monitoring via the centralized hub. 3. What workloads use Spark in Fabric? Spark drives Lakehouse ETL, ELT, data preparation in notebooks, and large-scale transformations in data engineering. In data science, it supports machine learning training with MLLIB, Synapse ML, and experiment tracking via ML Flow. Structured streaming handles real-time ingestion from event hubs or files into Delta tables. Batch scoring, predictive analytics, and integration with Power BI via Direct Lake mode for semantic models. 4. How does Spark access data from OneLake? Spark uses ABFS paths or relative paths in attached lakehouses for direct access to files and Delta tables in OneLake. Shortcuts enable virtual access to external data without duplication, treating it as native OneLake storage. Delta Lake format provides ACID transactions and efficient reads, writes with schema enforcement. Native optimizations like V-order and query folding accelerate performance on OneLake resident data. 5. How does Fabric manage Spark clusters? Fabric offers starter pools for pre-provisioned, fast start clusters and custom pools for configurable node sizes and autoscaling. Dynamic executor allocation and high concurrency mode optimize resource sharing across multiple notebooks or jobs. Capacity-based autoscaling adjusts vCores dynamically, with no manual node management required. Monitoring hub and resource usage UI provide real-time insights into executor allocation and job performance. 6. How does Spark support large-scale data processing? Distributed processing across executors enables parallel execution on partitioned datasets in OneLake. In-memory computation with RDDs and data frames accelerates iterative algorithms and transformations. Integration with Delta Lake supports efficient upserts, merges, and time travel on petabyte-scale tables. Autoscaling and dynamic allocation handle varying workloads without fixed cluster sizing. 7. How does Spark handle distributed computation? Spark partitions data across executors, executing tasks in parallel on worker nodes. Driver coordinates job stages, DAG scheduling, and task distribution via yarn-like resource management. Fault tolerance through lineage recomputation recovers lost partitions without full restarts. Shuffle operations and broadcast joins optimize data movement in distributed environments. 8. How does Spark optimize query execution? Catalyst Optimizer generates efficient physical plans with predicate pushdown and column pruning. Tungsten Engine uses whole stage code generation and off-heap memory for faster execution. Adaptive Query Execution, AQE, dynamically coalesces partitions and optimizes skew handling. Native Execution Engine, VLOX-based, offloads operations for significant performance gains. 9. How does Spark manage memory and caching? Unified Memory Management allocates space dynamically between execution and storage. Persist and cache store data frames, RDDs in memory or disk for reuse across operations. Off-heap memory via Tungsten reduces GC overhead in large-scale processing. Configurable storage levels and eviction policies balance memory pressure. 10. How does Spark handle fault tolerance? Lineage tracking recomputes lost partitions from original data without checkpoints. Checkpointing in structured streaming ensures exactly once semantics with state recovery. Driver and executor restarts via Cluster Manager maintain job progress. Delta Lake ACID transactions prevent corruption during failures. 11. How does Spark support machine learning workloads? MLLIB provides scalable algorithms for classification, regression, clustering, and recommendation. Synapse ML extends with deep learning, anomaly detection, and cognitive services integration. MLflow autologging tracks experiments, parameters, metrics, and models natively. Distributed training with Spark data frames enables handling massive datasets. 12. How does Spark integrate with Delta Lake? Native Delta Lake support enables ACID transactions, schema evolution, and time travel on tables. Operations like merge, UPSERT, and optimize maintain data quality and performance. V-order and Z-order indexing optimize file layouts for query acceleration. Unified batch and streaming writes ensure consistent processing paradigms. 13. How does Spark handle streaming data? Structured streaming treats streams as unbounded tables for declarative processing. Sources like event hubs, Kafka, or files support continuous ingestion with checkpointing. Windowing, aggregations, and joins enable complex event processing. Syncs to Delta Lake provide exactly once guarantees and incremental updates. 14. How does Spark manage resource allocation? Dynamic executor allocation adjusts based on workload within pool limits. Fair scheduling shares resources across concurrent jobs or notebooks. High concurrency mode enables multiple REPL sessions in one application. Capacity units map to V-cores, with bursting for peak demands. 15. How does Spark integrate with notebooks? Notebooks provide interactive PySpark, Scala, or R sessions with rich visualizations. Lakehouse attachment enables direct table, file access and auto-registration of Delta tables. Magic commands like %%SQL and %%configure customize sessions. Copilot and inline completions accelerate code authoring. 16. How does Spark support multiple programming languages? PySpark for Python, Spark Scala for JVM, Spark R, and Sparkly R for R integration. Unified Data Frame API ensures consistent operations across languages. Language-specific libraries like Pandas API on Spark enhance productivity. Notebooks support multi-language cells in single sessions. 17. How does Spark optimize joins and aggregations? Broadcast joins eliminate shuffles for small tables. Shuffle partition tuning and AQE handle skew and coalesce post-shuffle. Bucketed joins on pre-partitioned delta tables avoid expensive shuffles. Aggregate pushdown and partial aggregations reduce data movement. 18. How does Spark handle schema inference? Automatic inference from sources like Parquet, JSON, or CSV during reads. Schema on read with explicit casting for consistency in transformations. Delta Lake enforces schema on write, preventing drift. Evolving schemas supported via merge with column additions. 19. How does Spark support incremental processing? Change data feed, CDF, in Delta Lake tracks row-level changes for incremental reads. Structured streaming with watermarks handles late data and stateful operations. For each batch enables micro-batch processing with custom logic. Optimize and ZORDER maintain file efficiency over incremental writes. 20. How does Spark integrate with SQL endpoints? Delta tables created via Spark are queryable through Lakehouse SQL Analytics endpoint. Mirroring synchronizes tables for high-performance TSQL access. Direct Lake mode in Power BI falls back to Spark for complex queries. Shared metadata ensures consistency across Spark and SQL workloads. 21. How does Spark handle job scheduling? Spark job definitions enable parameterized, scheduled batch executions. Pipeline activities invoke notebooks or SJDs with triggers. Continuous mode for streaming via long-running notebooks, with always-on capacity. Monitoring hub tracks scheduled and ad hoc runs. 22. How does Spark manage concurrency? High concurrency mode shares sessions across multiple notebooks, users. Optimistic job admission allows bursting beyond base cores. Fair scheduler prevents starvation in multi-job scenarios. Capacity throttling queues jobs during peak contention. 23. How does Spark ensure data consistency? Delta Lake ACID transactions guarantee atomic writes across concurrent operations. Optimistic concurrency control with conflict detection in merges. Idempotent designs and checkpoints prevent duplicates in reruns. Schema enforcement blocks incompatible writes. 24. How does Spark optimize cost and performance? Autoscale billing charges only active execution time, with no idle costs. Dynamic allocation and autoscaling minimize over-provisioning. Native execution engine and vOrder accelerate queries significantly. Monitoring and advisor tools identify inefficiencies for tuning. 25. What are best practices for using Spark in Fabric? Use starter pools for development and custom pools for production with dynamic allocation. Apply medallion architecture with incremental processing and delta optimizations. Leverage MLflow for experiment tracking and Git for version control. Monitor resource usage. Enable high concurrency, and implement robust error handling. Thank you for watching. If this video helped you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.